Okay, we're setting up for an exploration to look at the average rate of change. So the first thing I want you to do is go to Desmos, and the URL is desmos.com/calculator. And that'll give you a page like this. The next thing I would like you to do, you see how I'm signed in here? And it's letting me, it has untitled graph as a name, and I can save. As soon as I do something, I can save it. I want you to make an account or sign in if you already have an account. And that way, all the work that we're going to do can be saved and we're going to use it again. So that would be really helpful. Okay, so now here we go. I want to start with A equals 1, B equals 2. And now I want to enter a function. Let's be super creative and enter f of x is equal to x squared. To get the exponent, I use the caret key. Let's see if it shows up as a caret. No, so in Desmos, it only raises the cursor, but it's that little, it's the character above a 6. All right, the next thing we want to do is define 2 points. These points are going to live on our function because we're going to set it up that way. The first point is a comma f of a. So f is the function we're using, and a is, at this point, a is 1. The next point, so creative, b f of b. And I'm tapping in this little box that says label so that I can see my point. Now, the average rate of change is a slope. It's the slope of a line that cuts through a graph at 2 points, and that line is called a secant line. Let's find the slope. M equals, I'm going to hit the /. That'll give me a fraction. In the numerator, the y values, f of b minus f of a. In the denominator, the x values, b minus a. And you see that it actually gives me a slope, 3. So the slope of the line that joins these 2 points is 3. Now we want to see that line because that would be really helpful. So we're going to use the point slope form of a line, y minus y1, but for us, we're going to use this point a f of a. So y minus f of a is equal to m times x minus a. And there's our line. Pretty groovy. And now we need to adjust some things. Just one moment. Okay, so the first thing that we're going to set up is the X and Y max and min values, and also the step, the number of spaces it takes before we see a number. We're going to go to this little wrench in the upper right. I'm pressing it. And let's just start with something a little bit small. Let's go -4 to 4 on the x-axis with a step of 1. And how about -3 to 3 on the y-axis, also with a step of 1. Now, it looks almost like, well, it doesn't look at all like this square. There's a button here called Zoom Square, and we are going to press that because we do want to have the X and Y axes at this point anyway. We want them to be the same. All right, and now we're going to set up some settings on A. So let's go up to A equals 1. I just tapped in that pane. See, if I tap into B, I get a min and max and a step. So I'm going to tap into A, and let's see. Let's change the values for A to -3, -3 to 3, and I want a step of 0.01. Now I want to go into this little double arrow thing, and when I hover over it, it says animation properties. Tap on that, and we want the speed to be slower than 1 times. So let's go down to 0.35. So do you see? And now we are going to, actually, I want to be able to see both points. Excuse me. We're going to tap on this. Moment, por favor. We're going to tap on this triangle to the left of A equals 1. And that is going to let A move between -3, and +3. And I think I want to narrow it. Let's make it go from -2 to 2.5. How about that? And I may just, there we go. Now we can see everything. So all I did was hit the little minus sign. What I want you to see is that this secant line, and I'm going to tap on here's the triangle, and then there's a pause. This secant line changes slope as the second point moves around. So unlike a line, like if you've got a physical line, that line has one slope. Well, a parabola doesn't have one slope. Every 2 points that you join will have maybe a different slope. And you can see that. And in fact, here we've got a positive slope. Does it ever go negative? Oh, wait, we've got to fix it. So let's go back to -3. There we go. So if I let it go up to -3, then here's a positive slope. Gets very steep. Let's pause it for a second and look at the value of M, of our slope. So right now it's 4.3. Let's see if it gets even higher. Oh, well, it looked like 4.3 was about as high as it got. And then as soon as A is vertically above B, the slope is negative. So let's see what we can do. Let's play with this function. Let's see what happens. First, let's just do something boring. Let's put a negative in front. So this space in front of x squared is what we call the coefficient of x squared, and a negative sign is the same as a -1. That flips the function. And if we let everything go again, we get the mirror of the values of the slope that we got before. So in the first case, positive 4.3 was about as large as we got. Now negative 4.3 is about as low as we get. What happens if we change the coefficient to -2? It looks like it narrows the parabola. And that means that the slopes, let's see, let's let A get closer to B. The slopes should get bigger. It looks like they're going to be about double. Let's see if that really works. Let's see what happens if we try 3. And I'm going to set this to go from 1 to 2.5 so that we can see it. Come on. There you go. And yes, you can see that we are just about tripling. We had 4.6 or 4.3, and now we've got -16.56. So pretty cool. That's what happens when we multiply the x squared term of a quadratic by a positive number larger than 1, or a number larger than 1. What about 1/2? Oh, I see what happened. So we've got, let's see, multiplying by 1/2 made the parabola wider, and it looks like it's making it take longer to move through its paces. Let's go back to -2. In fact, let's go back to -3 so that we can see the negative slope as well. So there's positive, it's going uphill. And out. And now it's negative. Okay, I'm going to pause that. And now let's look at a different function. Let's look at ½ x. And I know you all know mx plus b is a straight line. And here that it's 1/2 times x plus 0. So the y-intercept is 0, 0. And the slope is 1/2, up 1 over 2. So yes, up 1 over 2, that works. But what happens when the function that we have is a straight line? So I want you to notice something. When I tap into the pane for f of x equals 1/2 x, I see a green line. When I go down to y minus f of a equals m times x minus a, I get that dark blue line, but it's the same line. And if we let a vary, the average rate of change between 2 points on a straight line is exactly the slope of the line. So what if we have a rational function? Let's see. here, since this function is not defined when x is 0, and when x is not 0, we've got two separate parts. So I want to set this so that both points, A and B, are on the same section of the rational function. So let's call this 1.4. There we go. It almost looks like the line is not crossing the function, but let's zoom in and see it better. And now it's easier to see that indeed. Oh, I wanted 0.4. Okay, groovy. There we go. And there you can see that we're cutting this graph in two places, and that the graph, this secant line, this line that's cutting the graph, is always having a negative slope. That's because 1 over x is a decreasing function. So let's have some fun. Let's just make it a negative 1 over x. And we can see that it is an increasing function. It goes upward as we move from left to right, and that the slopes are all positive. The slopes get steeper as the values of x get toward 0. Let's try. Let's see, I'm going to take that negative away and put a 3. All right. And 3 over, I'm going to blow up. So let's see, I want to change this from 0.4 to 0.8. That's right here. Yes, that'll show it. Let's change this upper value to 4. Oh, I forgot to tell you. Do you see here? We've done all these things. It says untitled graph save. Because I'm signed in, I'm going to hit save, and I can save, and I'm going to call this rates of change. We will use this again, and so I want you to have an account in Desmos and start creating and saving these systems that we're going to set up. So you can see that just like with 1 over x, 3 over x is always decreasing. It's going downhill as you go from left to right, and the slopes are all negative. I think that's good enough. What you're going to do now is finish the exploration and answer some questions. So the questions are asking where, if the slope of the secant line changes sign from positive to negative or negative to positive, where does it change? And if it doesn't change, what sign does it have? And then you're going to change some coefficients of some of the variables and play with things, look at the shapes of the graphs, look at whatever happens, and just play with these parameters. I really want you to have a dynamic understanding of rates of change and also how those relate to different kinds of functions. All right, thanks.